Okay, let's go ahead and take a look at the rest of our law of sines. This might become 2 more videos instead of 1 more, depending on how long these examples take. But let's revisit, right? So we're using the law of sines ratios to solve triangles. Now, the 2 examples we did already were specific triangles because we knew 2 of the angles, and so obviously if we know 2 angles, we know the third, right? So if you look closely and if you remember from your geometry days, if I'm given a side and then I know an angle and I know another angle, then this becomes side, angle, angle, or angle, angle, side, right? So this is angle, angle, side. A perfectly good triangle. We know the ratios. It's allowable to determine if things are congruent and so forth. Solvable by law of sines easily. Our second example, if you look at our triangle, right? Again, we knew an angle. We knew the side here, and then we knew the angle. So this is angle, side, angle. And if you remember from geometry also, angle, side, angle is used to prove congruency and so forth, similarity. Again, good triangles. We know 2 angles. You know the third angle if you know 2. Now here's where it's going to get a little tricky though, because what happens if I know 2 sides of a triangle, right? So let's say you know the side of a triangle and you know the side of a triangle, and then let's say you know an angle, right? So we don't know if it's going to go this way, right? We don't know if it's going to go this way. We don't know if the angle is going to be obtuse and go out this way, and if it's even going to connect. Right? There's a lot of unknowns in that angle. So I want you to pay attention, right? This is angle, side, side, right? So when you're dealing with angle, side, side, right? We write it side, side, angle on purpose, right? When we're dealing with these kinds of triangles, it's not a good tool to prove similarity or congruence because there are some unknowns with that angle. You don't know quite where it's going to be. And so what that's going to cause for us is it's going to make the problems a little bit harder because now we don't know if there's a possibility that no triangle exists, right? If the angle goes out like is obtuse, and this is obtuse, right? These are never going to connect, so there's a possibility that there's no triangle. I could work it out just fine and find out that there's one exact triangle, but I could also work it out to where maybe this line comes out this way instead of going out this way, and then there's a possibility of 2 triangles, right? And so there's some more studying to be done. So we're actually going to do 3 more examples. And like I said, we might just do 1 now and then 2 in another video, depending on how long this goes. But don't get confused, right? I'm going to walk you through it. And it's not something where I expect you to be an expert. I want you to be familiar, and I want you to know how to use law of sines, but you do not necessarily have to know for a quiz, specifically 2 triangles, 1 triangle, no triangle, and so forth, okay? All right, so let's look at an example and get started so we can take a look. So let's say we have a triangle where we know A is 3, B is 2, and we know alpha is 40, right? So notice side, side, and the angle that starts it, right? Okay, so if we were to draw this out, right, and we assume we have a triangle, which we cannot, but let's say we have a triangle. And so let's say you say alpha's here, right? A, B, C, and it doesn't matter. We're not really drawing to scale, right? But B is going to be 2, A is going to be 3, and alpha is 40, right? So we don't really know what's happening in these other 2 angles. They could all be acute angles, right? One of these angles could be obtuse and the other one could be smaller, right? We don't know what's happening. And so that's going to cause us to solve a little bit more when we're solving, right? So we're going to have to pay a little bit more attention. So like before, we're going to go ahead and write out what we know so that we could see what ratio we have. And we'll go ahead and use our Greek letters, right? And we don't know any of those. So now the question is, do we have a ratio? Can we even use law of signs to solve this? And the answer is yes, we have the ratio of the a's, so we're okay there, right? We're going to use this ratio to start solving. Now, can I solve for whatever I want this time? Well, the answer here is no, and the reason for that is because we only know 2. So we have to find beta so that we can find gamma to find C, right? We don't know C, it's not a right triangle, so we can't do Pythagorean theorem, right? It's not quite like the other problems, and so this is where we have to be creative in what we're doing. So we're gonna first say, right? We're gonna say that sine of 40 over 3 is equal to sine of beta over 2. And so first of all, notice it's a little different because we have to solve for the angle, right? And we really haven't had to quite do just that yet. So notice I want this by itself, so I'm going to go ahead and multiply both sides by 2 so I can get rid of that. But notice this side is all ready to go. I don't need to move the 3 over here because then I'd have to get it back. So this, in this regard, we're okay here. So we're going to say 2 sine 40 over 3 equals, and I'm going to leave a little space there so we can solve for the angle, right? Sine of B. How do we undo sine to get B by itself, right? So now we're saying, how do I get B by itself? How do I get rid of sine? Well, if you remember correctly, when we're solving for angles, we're going to do inverses, right? And the inverse of sine is just that. It is the inverse of sine. So we're going to say the inverse of sine, right? So sine inverse and sine will cancel out. But whatever I do on one side, we're going to do to the other, right? So we're going to do sine inverse of all of this. And I didn't calculate this out first because then I'm just going to get decimals there, so I might as well put it all into the calculator at one time or into Desmos, right wherever I have it. So let's go ahead and do this. So we're going to get inverse sine, right? So inverse sine of fraction, if you will, right? So that it doesn't become too complicated. 2 sine of 40 all over 3. And so you want to make sure that what you have here is what you have here. I'm going to go ahead and do Control Enter, and that gives me 25.373. Okay, so we're going to say for now that beta is 25.374, right? Because 3739, so I'm going to put 374. Right? Now here's where here's where it's going to get a little complicated, because I cannot just take this as solid fact. Right? I need to do some investigating. And so we need to figure out, do I actually have 2 triangles? Do I have 1 triangle? Do I have no triangle? Well, first I would tell you we have at least 1 triangle, because 40 and 25 is 65. And so C still has an angle to B. But what I want to find out is, do we have 2 triangles? And the way we're going to determine if we have 2 triangles is to also do, to find the supplement of B, right? And so basically we're going to determine if B is the answer or if the supplement of B is the answer, right? or beta, I suppose, right? And by supplement, I mean 180 degrees minus that, right? Because a supplement are the two angles that add up to 180. So we're going to look at that, which the supplement of B is 154.626. Okay, so we're going to call this B1. So right now I have 25.374, or, right, I'm going to make a second column here, or I could have 154.626. Okay, and again, we're looking at the supplement to see if it's the angle opposite, right? So two angles, right, make a triangle. What we're trying to determine, is it the 25-degree angle, or is it going to be the larger angle that's created, right? That's why we look at the supplement. So we're looking, here I said it was 25, but could it also be the supplement, right? Forming two possible triangles or just one. Now here's how we know, right? So if I determine the supplement is 154, can I even find the lambda for that, right? So here, 40 and 25.374. Here, if I add these up, I'm going to get 65.374. Subtract from 180, we're going to get 114.626, right? If I do the same, because this would also have to be 40 degrees, that one's not going to change, right? If I take this, I'm already at 194. Well, that's too big. A triangle is 180 degrees, right? So this would be too big, right? I cannot do. So how do I know what answer I have? Well, I have one specific triangle, right? So since this doesn't work, right, since lambda 1 would be impossible for a triangle, right? It's not sine. Since lambda 1 would be impossible, right, we know there is only one triangle. Cannot spell triangle, right? So that's how we know if we have one triangle, two triangles, or no triangle. So in this case, we have one exact triangle. We've already got the angles figured out. So we found B, we found C essentially, and now we can use our ratio to find C. Now, we don't have a choice. We have to use the answer here because we haven't, that is the angle that we have. So we're going to go ahead and do our second step here. Use our ratio, sine 40 over 3, sine 114.626 over C is what we're solving for. Right, and so we're going to calculate that. So on this one, when we're solving, right, I got to get C out of the denominator, so I'm going to put C up here to get rid of it. I am going to multiply by 3 though to get rid of it here, so I'm going to multiply by 3. But then I have C here, so notice I'm also going to divide by sine 40, right, to get rid of that sine 40. So that would give me C equals, and I'll write it out this way for just a second, divided by sine 40, and then we can plug that in the calculator, right? So we'll get 3 sine 114.626 divided by sine 40. And so we'll get 4.2426 or 3. And so this is going to be, C is, what did I say, 4.243. And so we can come back up here and say 4.243. And then again, always good to check to make sure my smallest angle has my smallest side, my next angle has the next side, and my biggest angle has the biggest side. And that's our solution. Okay? So we'll go ahead and do 2 more examples in another video. Bye.